Hey everyone, so today we're going to be looking at page 693 of your Physics 30 textbook, and we're going to look at practice problem 2 there in the bottom right hand corner. It asks how many lines per centimeter are there in a diffraction grating if the third dark fringe is 5 centimeters from the central antinode when the screen is located 60 centimeters from the grating. Assume that the wavelength is equal to 500 nanometers. So let's write down what we know. We know that the third dark fringe is located 5 centimeters from the central antinode. Now let's not get confused here. They have said dark fringe, and dark fringes occur between antinodes. So if we look at the diagram here, the third dark fringe is actually located between the second and third antinode, which means the value for n in this example is 2.5. They tell us that the dark fringe is 5 centimeters away from the central antinode, that the screen is 60 centimeters away, and that the wavelength is 500 nanometers, which we can convert to meters and say 5 times 10 to the negative 7 meters. So what we need to determine is how many lines per centimeter, which means we need to determine the distance between the lines, or in other words, the distance between the slits, distance d. Once we find this distance, we can divide 1 centimeter by the distance between the lines, and that will tell us how many lines there are in 1 centimeter. So let's look at this picture right here of what I mean by number of slits per centimeter. Here I'm assuming that I have a diffraction grating that is 1 centimeter long, and I know that the distance between each one is 0.125 centimeters. That means there are 8 slits within 1 centimeter, or in other words, 8 lines per centimeter. So let's look at a formula. So if we look at our data sheet, there's one formula that we can use to determine the wavelength in a diffraction grating, and that's lambda equals xd over nl. To solve for d, we're going to need to rearrange the formula by multiplying both sides by nl and divide both sides by x. This is going to give us d equals lambda nl divided by x. So if we substitute everything in and then put it into our calculator, we get 1.5 times 10 to the negative 5 meters. But we're interested in centimeters, so let's multiply it by 100, and we're going to get 0.0015 centimeters. Now that we know our value for d, we can determine the number of lines per centimeter because we know that 1 centimeter divided by d will equal the lines per centimeter. Substituting in our value for d, we can find that there are 666,666 lines per centimeter, which if we round to the correct number of significant digits is 6.7 times 10 to the 2 lines per centimeter in that diffraction grating.